performance engines. And this is the 455 block I told you about in the first video. And I just got it back from the machine shop and it looks great. I'll tell you a little bit about it. This is a 1971 455 and it's a 325 horse out of a 71 GTO. You can decode that through right here. They stamped the little block code. It's a YC code. And in the back, they have a date code back here, and it says 71. The block casting number also will tell you basically what size motor it is and sometimes what kind of car it came in. This is a 485 428 block. Just to run through this real quick, what happened to it was a standard bore block that had a little bit of a ridge when I took the heads off, and it never really had an issue. The bearings even look good, the cam bearings look good. Probably had about 150,000 original miles on the motor. The block, all the freeze plugs were removed. The block was stuck in a hot tank and all the internals were cleaned. Ran water through there and what's called a caustic acid solution, which loosens up all the crud that's in there around the cylinders, and then you flush it all out till it comes out clean. This one even is stamped on the side, 455. So the first process that was done was the line hone of the main saddles. So these, in blueprinting a block, this is the first process. So what you do is you take the caps, you file the surfaces, you take the caps, you cut them roughly about 2 to 3 thousandths, and you bolt them back in place. I was using ARP studs, which sometimes the difference between a stud and a bolt, it changes the cap deflection just a little. So it's always recommended not to just change into the studs. Always set it up, stick a vial bore gauge in, and check the measurement to make sure. So it's put on a machine, the caps are cut, they're put back on, and now the circle is actually smaller. A giant hone that's about maybe 4.5 feet long is inserted through here, and it align hones, just like the name says. It aligns all of them when it hones, and it hones it to the perfect size, like as if it was new. First process. Then the block is taken then, and a bar is inserted through the line, through the main system. A bar is inserted through the main system. It's put on a machine, and the top of the deck is cut exactly parallel with the main web. And that's the second process in blueprinting a block. Now, to zero deck the block and bring the piston exactly to the top, you have to assemble it, check it, put it back in the machine, and cut as you've measured. Next process is the boring bar that cuts the hole for the new cylinder, which these are 30 over, the next size over from standard. The boring bar is placed on this deck, which has been cut parallel to the mains, and the boring bar cuts exactly 90 degrees to the deck surface it sits on, which is the cylinders. Okay, after that process is done, the block is basically blueprinted. The 3 main surfaces, where the crank goes, where the heads go, where the pistons go. Everything is aligned and checked and blueprinted. And that's a basic blueprint of a block. Now you can go through checking the angle of the lifter bores, you can go through a lot of other measurements, but that's basically a blueprinted block. Now, the next process that we're going to do now is, so I just got it back from the machine shop. They already installed the cam bearings. And what I'm going to do is, I took it outside and I use this Ajax mixed with water. I use a lot of this concentrated. And I use a garden hose and I scrub it, clean it, get all the residue off, because even though it's been through a hot tank system, there's still a residue on there and I don't really like. I just want to get it off. After that, you have to have the ability, an air compressor with a blower, to dry the block instantly. Otherwise the machine surfaces will instantly start to rust. So you want a can of WD-40, an air blower, be right there when it's done, blow it all out, everything will be great. You wait 15 minutes, it's going to start rusting, surface rust, instantly. After that's done, I take an alcohol wipe and I clean out all the cylinders. Because if you look at the cylinders, when they're home, there are peaks and valleys, and if you put a little pressure, you can get it to be dirty when you pull it out. So you definitely want to clean it. You want it as clean as possible before you start. Then I coat them with a liberal coat of WD-40 and a nice clean terry cloth rag to clean it. The first process we're going to do is we are going to put the main bearings into the saddles. These are a Cleveite standard size main bearing, and it's an H series. They have a bevel, as you can see, cut out for crankshafts that have a large radius on the sides, and I'll show you that. Because if you don't have the bevel cut, when you put it together, the radius touches the bearing and it feels like it's rubbing or scrubbing, and it's an immediate stop what you're doing. So I'm going to insert all the bearings into the saddles, and on this exact motor they are marked upper and lower, upper being the block, lower being the cap. They are marked, so you've got to pay attention when you look at that. Snap into place. Feels really good. It's freshly lined home, so the bore size is supposed to be exactly right, and the bearing should have some tension. It shouldn't just slide in, fly out. Either the bearing's made wrong or the hole is too big. Feels really good. Okay, I'm going to put all the others in, and I'll be right back.